Today we're going to get a jump start on looking at our order of operations. Sorry, not order of operations. Operations on functions. There are 5 of them, and 4 of them are the basic algebraic operations: addition, subtraction, multiplication, and division. And then functions also have a 5th operation called composition, which we're going to save, and I'm going to put that into a separate video later on. If you're looking at your list of things to know and list of things to do, today's video is going to cover these definitions of sum, difference, product, quotient. It's going to cover finding those for specific inputs. That means an actual value for x. And we're going to find it for new functions. We're just going to we're not going to use any numbers. It's just going to be putting 2 functions together to create a new function, and a little bit of work on finding the domains of these new functions. Those are the 4 objectives for this video, and we're going to get right into it. Some of this you may have seen before. You just need a reminder, but I would say for most of you, looking at the domain piece might be new. So for the sum of functions, if I have 2 functions, f and g, and I want to add them together, we would write it f plus g of x. Remember that this is function notation, so this is not multiplication. And that would be equal to f of x plus g of x. I know it looks like distribution. It looks like we distributed the x to the f and the g, but that's not what we did. This is a function operation. And what it really says on the left is that I can put the 2 functions together first. If I'm looking at the left side here, it's by order of operations. It would say, let me get a different color here. Add the 2 functions together first, and after you've added the 2 functions together, evaluate them at x. As opposed to the left side, the right side, which says, well, you could find f of x, you could find g of x, and then you could add them together. So it's a matter of being able to do that in either order. And generally, it's easier to take the individual pieces, get the answers, and put them together afterwards. And so that's what the sum of functions is. The difference of functions, much the same, except we'll be using subtraction. So f minus g of x is equal to f of x minus g of x. The left side says I could subtract the 2 functions, write a new function, then put x into the new function. Or the right side says I can find f of x, get an answer, find g of x, get an answer, and subtract the 2 answers. Just as one quick point of emphasis, we can work with these rules. Let me see if I have a good thing here. From right to left, but also, from left to right, but also from right to left. That equal sign between the functions allows us to work in either direction. So difference of functions. The product of functions, parentheses, f times g of x is equal to f of x times g of x. Same idea. I can multiply the functions first. That's what it says on the left. I can go ahead, multiply first, and then evaluate at x. Or I could find individually f of x, individually the g of x, and then multiply together. So you probably saw this in Algebra 2, so this is a bit of a review just on the notations. What's probably new from the pre-calculus portion of this is that the domain for any of the function operations is the intersection of the individual domains of f and g. And we're going to do a lot of domain writing, so we're going to want to be able to do that. So basically what you would do is you would find the domain of g, of f, pause there, you'd find the domain of g, and you would see where they intersect, see their intersection. And we'll do an example of that in a minute. Just one word of caution, something to be careful for, is that while we can do this for operations of functions, we can add the functions together, the same does not apply if we're adding inputs. So while we can do f plus g of x and make it f of x plus g of x, we cannot, no, bad, take f of x plus y and split it into f of x plus f of y. So that's bad for business right there. We can't do that. Just a little point of emphasis. The quotient of functions following the same line that we've been working on. If I have two functions, I divide them, then evaluate it at x. That's the same as saying I could figure out f of x, I could figure out g of x, and divide them. The only thing I have to be careful for here is that g of x cannot be equal to 0. If g of x, whatever value g of x makes g of x equal to 0, would give us in the 0 in the denominator, and we can't have division by a 0. For the other functions, it's not a big deal. If for my g of x, I can, if this number was a 0, no big deal. I can add 0. If this number was a 0, no big deal. I can subtract 0. And if this number is 0, it's fine. Multiplication by 0 is defined. I get an answer. The answer would be 0. It's not very interesting, but the answer still exists. But in this particular case, if this ends up being 0, that would be bad for us. So we're not allowed to do that. So we have to be careful. So because of that, when we have the domain of a quotient of functions, we do the same thing that we did before, that we will go ahead and find the intersections of the domains of f and g, but from that set, we've got to get rid of the value that makes g of x equal to 0. So now you can see why we worked out the domains of functions earlier in the year, because we're going to start applying it in another case. So if you weren't so good at it earlier and you still need some help on that, we'll get some work going. We'll continue to practice. So that's it for the information. At this point, I'm going to do a couple of examples to help you see what's going on. I'm going to put that into a separate video. And so you can pause here and then go to the next video to watch the examples for this.